I've worked with at various times on customer issues. I've also done, seminars, teaching, training opportunities like this one. Topics, they center around JD Edwards performance issues, but I try to convey general principles as much as possible. Also, we try to include case studies of actual customer issues, actual usage. In today's case study, though it is kind of a semi-tutorial in Performance Workbench, it'll include data that isn't contrived data. It's actual example data from customer issues, because I'm kind of a practical kind of a guy. Believe in a practical approach when you're imparting practical knowledge. Hopefully, we try to keep the topic as interesting as possible as well. So that's a little bit about me. About the topic here today, you notice that it says 2012 Partner Summit. Well, that really should say 2013. Okay, I gave this topic at the Partner Summit this year. That's held up in Broomfield every year. It's a set of slides that in one form or another, in a slightly tweaked format, has been around. I don't know, I gave it for the first time maybe 4 or 5 years ago. I don't think I've ever gave it to this audience, though, which is why Clayton suggested that we use this topic. So that being the case, we'll go ahead and start. And by the way, just as a matter of housekeeping type issues, I prefer to save questions till the end. So if something comes up and you think, oh, what if this? If you could just write it down, and at the end I'll give an opportunity for any questions that people might have had. Here's our slide that makes attorneys and people in the General Counsel's office happy that this isn't forward-looking, this isn't guaranteed, whatnot. So somebody's phone is ringing there. Not sure who that is. All right, well.
Welcome to Verizon Wireless. The wireless customer you called is not available at this time. Please try your call again later.
I don't know.
Announcement 1-18-2. Welcome to Verizon Wireless. The wireless customer you called is not available at this time. Please try your call again later. Announcement 1-18-2.
Not sure if you're all hearing that, but if somebody dialed in a cell phone, Verizon is, trying to get your attention. There you go. All right. So Performance Workbench, maybe a lot of you have used it. I don't know, probably almost all of you have heard of it, maybe. Some of you might use it, but aren't really fully aware of all the ways that it can be used or should be used to get maximum value out of it. Anyway, it's commonly used by field support customers and our internal developers to do a variety of things. You can see there's a couple of quotes. Use it every day. Without being able to use it, my troubleshooting is hampered, etc., etc. A lot of people maybe want to get started using it to analyze Enterprise One code and to solve Enterprise One performance problems. Now, first of all, what is this slide deck, this 1-hour presentation, give or take, not? It's not a comprehensive, exhaustive tutorial on Performance Workbench by any stretch of the imagination. There's 2 places you can get that. Number 1, there are detailed help files included with the product that include about 11 or 12 usage samples. So the help files, I think, are pretty extensive with a lot of graphics, a lot of pictures, things like that. So you should take a look at those. The second is there are a good many recorded web presentations in addition to PDF slide decks on the JD Edwards Enterprise One Performance Library. If you haven't seen that, the MOS ID is 978.813.1. If you deal with performance issues at all on any kind of a regular basis, I guess you should be seeing that in your sleep. I don't know, get a tattoo of it someplace, whatever, and make up some interesting story about what it really means. Anyway, 978.813.1. There are several dozen presentations, again, some both slide decks, static slide decks, and recorded web conferences. They contain very specific examples of how Performance Workbench is used in many ways that are from detailed case studies that illustrate the use of the Performance Workbench tool in the context of performance engineering principles. Okay? There is a tool called PAMPARS we'll get into, or we won't get into. It's beyond the scope of this session. Okay? It's part of the Performance Workbench suite. It only works in certain contexts, certain versions of the product. We won't really talk about that today. So there's the Performance Workbench health file. There's how to get at the Performance Workbench samples as case studies. There's the Performance Workbench or the Performance Library for Enterprise One. Performance Workbench itself is available for download at 747.328.1 is the doc ID for that. That is also linked to 978.813.1, okay, in case you forget that. It is a self-extracting XC. There's no detailed installation procedure. Basically, it just copies files onto a drive you specify onto your, C drive or wherever. It also does some registry magic behind the scenes. So you can download that. And if you haven't downloaded it recently, there have been recent updates. So maybe you should make sure that you get the most recent version. Okay. So again, I have this hands-on graphic that's kind of a leftover from when I gave this at the Partner Summit, and people could log in and actually do these things. Don't know, you're probably not prepared to do that now, but anyway, you can download it, run the self-extracting XC. So what is Performance Workbench not? Okay, because there's conceptions and misconceptions about it. First of all, it isn't some magical device that just spits out a list that gives you a list of your performance problems. You got to do this, 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 and this, and your code will just scream. It's not like that. It's not going to replace a knowledge of performance engineering, nor make engineers out of technicians. Okay, any more than knowing how to use a circular saw makes you into a carpenter, right? You can read the manual of how to run a circular saw, and you can do a few basic things like cut straight angles, learn how to use a miter box, all things like that. But building a house, just because you use a circular saw as a tool to do so, does not mean you understand how to build that house. Okay, does not mean you understand how to build a foundation, the order in which you're going to do things, plumbing, electrical, heating, ductwork, what the difference is between a supporting wall and a decorative wall, et cetera, et cetera. Okay, all of that is a level of knowledge that kind of transcends the tools. Okay, the tools are kind of a subset of that. The tools don't do you much good if you don't have basic knowledge on how to build the house. So it doesn't replace first principles of performance. Where is the code or system spending its time? And I repeat that phrase up, down, backwards, 6 ways from next Sunday in almost every deck I've ever given on performance. Okay, that is first principles. Everything else, really, I submit to you, starts from there, ends from there, or passes through that concept in some way, shape, or form. Okay. You shouldn't look for anecdotes from Performance Workbench. You shouldn't look for magic bullets. Okay, it's data. You need to analyze the data. Over on the left, the right, I've got a graphic of an MRI, and I guess from where I got that graphic from, it's got some colored spots on there that shows an MRI of a person who's got epilepsy. Okay, now can you tell that just from looking at that? I certainly can't. A couple of years back, I was coaching my boy in Little League, and I'm hitting ground balls on a really, sun-hardened field that hadn't seen rain in a while, kind of like we're having now in Denver. If you live in Denver, you know we've been very dry, very hot. And the ball took a bad hop, hit my son right in the eye when I was hitting on ground balls, okay, during practice, and it detached his retina. Okay, he's okay now, but point there is he had an MRI to make sure what was going on, and to make sure that when it hit the ball hit him in his dome, make sure there wasn't any fractures or any orbital bone fractures or anything. And they give you an MRI, and they gave it to me on a DVD. Right? You take that and you show it to your doctor. I guess they hadn't got anything online yet. Anyway, me being who I am, I said, well, I want to look at this and myself, see what I can see, even though I don't have any medical letters after my name. Pulled it up. I couldn't tell hide nor hair if there was a break, if there wasn't a break, just by looking at all these slices. The point is, somebody skilled at reading and interpreting the data has to look at it and see. It's not just a one-liner saying, okay, he's got a broken orbital bone and it's right here. Somebody has to read and interpret the data, a human being, and look at it. Otherwise, it's just a pile of data. Okay? And that's true for any profiling or memory tool, not just Performance Workbench, right? So the point is, there's many people that want to know how to use a tool, thinking that'll solve all their problems, when what they should be asking is how to analyze software performance, okay? Now, the details on the whole grandiose world of software performance isn't something we're going to start from scratch here for, okay? Rather, before we get into any technical details of Performance Workbench, you should know that it's useful in the context of understanding and applying first principles of performance, all right? That's a good segue into what it is. It is a tool which can be used to apply engineering knowledge more effectively to analyze and solve problems and make engineers more effective in doing their job, okay? So taking my house building analogy, kind of turning it on its head a little bit, you could have all the knowledge in the world on how to build a house, right? But if all you got is hand tools, well, you can certainly do it because people did it hundreds of years ago, even 1,000 or more years ago. People built homes out of logs with just an axe, okay, and sap and pitch to seal in, you know, the spaces in between the logs, and they knew how to build a chimney with stones they gathered from the river and all this stuff. But it would take an awfully long time, and you won't build as good of a house. Well, some would argue some of those houses were better than mass-produced homes today. But anyway, the thing is, if you have all that knowledge, but also you add in the fact that you know how to use power tools, and that you know how to use a nail gun instead of a hammer, you know, and just a box of nails, you can be more effective, okay? And you can do things much more efficiently. Okay, so someone who's got that knowledge plus the tools, that's a lot of power, okay? So what is Performance Workbench at its basic? Well, it is, again, a Windows GUI tool that takes as input data the debug logs from the Enterprise 1 Enterprise server and Jazz server. Those are the two main pieces of input it takes. So it leverages the information that's in the debug logs from Enterprise and Jazz servers. As output, it spits out summarized and statistical reports based on what's in the debug logs, okay? Basically, the reports that it gives you are profiling data. Okay, it gives you a profile given what's in the logs. Those of you that maybe haven't used Performance Workbench but know about debug logs from JD Edwards, they can get very, very big. They can get into the multiple gigabytes very quickly. Okay, and they are often very difficult to read and manually. First of all, you got to find an editor that can actually open it up, and you got to do all kinds of crazy things with it, and people try to use file splitters and whatnot. Point is, Performance Workbench will do data reduction on those files and give you, you know, tens of kilobytes worth of data that you can process quickly. In most cases, Performance Workbench can eliminate the need for third-party profiling tools. It doesn't pinpoint the final answer very often, but it can narrow the problem down to a point where easier methods can be used to find a resolution, okay? The data in the debug logs is centric to E1 and eliminates many layers of data that isn't useful for profiling. A lot of low-level calls, a lot of the way the code is modularized, many things in the call stack aren't really helpful. Profiling tools won't show you the text of the SQL, for example. I can get to the next slide here, or if I'm stuck. All right, so the next point is here, I titled the slide Garbage In, Garbage Out. That's basically saying that the logs you collect have to be the right logs. This tool is only as good as the data you input, right? The data you input has to capture the problem at hand, and you cannot be cluttered with extraneous activity. You've got to use the proper log settings. You've got to run against the proper use case and the proper configuration with a significantly large sample size, okay? Just because you want to analyze a certain app doesn't mean that you can just use any old log from any old instance of any application. It'll be just as irrelevant as, say, looking at any security tape when you're trying to catch a thief. You need the tape from the right day, the right time, and the right part of the store in order to have any hope of finding out who broke into the store and capturing that picture, okay? Because the wrong tape, and certainly one from the wrong store, even if it's the same time of day, is not going to work, okay? Even from the right store in the right time, if it's not coming from the right camera, it's not going to work, okay? That's what I call the light is better over here syndrome, that You know, the old joke about somebody who lost their car keys, right, maybe in the dark, in a puddle, you know, someplace that's hard to get to. Well, where are they looking for their keys? They're looking under a street light, okay, where it's very easy to look. And you say, why? Well, the light's better over here. Okay, well, maybe the search is easier, but you're not going to find it unless you get on your hands and knees actually be. Okay? So again, it's a garbage, only going to be as valid as the input data. Right? You've got to have attention to detail. So here's an example of that. We had from an actual case, a request from support. Apps development is assisting a particular customer with performance issues in several UBEs. We would like to ask the on-site resources to run the logs through Performance Workbench and send us the results. So-and-so suggested contacting to get the optimal settings from Performance Workbench. Well, what we told them is the optimal settings depend on what you're trying to do. The important thing to focus on is getting the right logs, and forget about the settings. You need to nail down the use case, the procedure for getting the logs. You know, make sure you have a large enough sample size and get that log. Once you have it, you can crank out Performance Workbench runs and tweak the settings as much as you want. That's not a problem. That's the easy part, okay? So my advice is that you don't have customers run Performance Workbench. You have them capture a log, okay? And depending on not on site or not, have them send the zip logs via FTP, and then you can run Performance Workbench. It's best to have the logs themselves, so we've got the freedom to iterate, run with different settings, different search items, you know, run SQL parse, etc., which we'll get into. It's a dynamic, iterative process, and it's very painful to be tossing logs over the fence, you know, just so that someone else can run them. The process is one that we don't usually run Performance Workbench just once. Okay, usually it's a multiple run type of thing. So it's the logs that are the important part. Performance Workbench is only as good as the data. All right. Along that same line, the customer's already generated a log prior to entering a case. There's a strong possibility we'll need to regenerate it. Okay. The performance team gets involved, because if you haven't followed the correct procedures and captured the exact correct log, okay, we're not going to capture the problem. So in other words, you can't just say get logs for sales order entry. It's too vague. Okay, it's too vague. The margin for error, you know, is kind of small here. An example I put is Shackleton's 1916 mission to go to Antarctica. When he went there and stayed there for months, and all these people without modern gear survived, right? But the problem is he had to leave, and he had to get to this small little island called South Georgia Island, which was in the middle of the South Atlantic. You know, and he didn't have GPS. He had an equipment called a sextant and a compass. And if he were off in the open ocean in his calculations by only a few degrees, he'd miss the island entirely. Okay, he had a narrow margin for error by which he could calculate his position. Oftentimes, you know, one little setting someplace and the way you capture these logs will make you miss the problem you're trying to capture. Another issue people have is saying, well, the logs files are too large. And I say most of the time there's no such thing, okay? That large logs, long-running processes, you can still use this method. I won't go into details, but on that Performance Workbench or the Performance Library, there are a couple of presentations in particular, Analysis of Long-Running Jobs and Performance Outside the Box. Those are titles of two other presentations that show how to use this method of capturing logs for processes that run really, really long times, like UBEs that run for several hours. Well, I can't run a UBE and keep logging on the whole time for 10 hours. You know, it's impossible. It'll take twice that long with logging on, and the logs will be so many terabytes, you know, they'll be impossible to do anything with. Well, there are happy mediums in how to collect logs from UBEs, how to sample. And I would point you to those documents for some details on how we've done that in the past. Second of all, I think that in the tens of gigabytes, we have those for breakfast. 100 megabyte, log files we use all the time. Newer PCs, faster processors allow Performance Workbench to run in very reasonable time frames. You can use WinZip to compress the file to, single-digit percentages of the original size, and you can use FTP. The UBE debug log used in a lot of the examples here were a gigabyte in size, and we're very capable of handling logs, that big or much larger. So in general, the bigger the better. Again, large data sizes and large overhead is true for other off-the-shelf profiling tools as well. Debug logs in some respects have less overhead than a lot of these tools because we don't require the code to be compiled in debug. You don't have executables that you've got to recompile, and recompiling, because we're centric around DLLs and shared libraries, you'd have to recompile all the shared libraries, all the business functions, and many other profiling tools require you to do that. So there are three tools that are part of the Performance Workbench suite we'll get into: LogParse, SQL LogParse, and Jazz LogParse. Okay? I would say first is LogParse, probably the most commonly used one. The inputs can be very large logs. The outputs are distilled, processed, and statistically summarized reports of what was recorded in the logs. Typically, the main components of debug logs are all business function calls, all SQL that was called, middleware and tools APIs, event rules, system functions, and other configurable items you can configure and turn on and off through various I&I settings. For enterprise server logs, most commonly you're going to be analyzing UBE logs or call object kernel logs. UBE logs tend to be easiest because it's one process, one thread only, and it has a logical beginning and an end, and it's kind of a neater package. The profiling data is usually based on business functions, SQL, and other searchable items. Okay, the executable looks like that, for those of you who haven't seen it, and your input log goes up at the top for all three of these: LogParse, SQL LogParse, and Jazz Parse. The best initial settings, okay, you can see that this user interface has a lot of different checkboxes and settings and input values. I've given you a list of ones that I think, for most general purposes, are the good ones to start with. You set them, you click on the Save Settings button, and then they'll be saved in the registry in that machine. Parse level 5, log additional APIs checked. Generate a timing gaps file and the timing levels and gaps, okay. Those tend to give you the most information that's useful most of the time, okay. So I would use those settings. For the Edit Debug Strings box, okay, I would type in Select, Insert, Update, Delete in all caps, because those will search for those statements and put them in the proper place in, as we'll see, the call stack files. So when we had this as a hands-on exercise, there was a sample UBE debug log which we looked at, okay. There are output files that get launched automatically. For those of you who haven't really used Performance Workbench before, an underscore summary, which is HTML, and an underscore timing in plain text. This is what it looks like when it's running. This is what it looks like when it's done, going from the top to the bottom. Okay, it shows you that it's running by pulling up a little command screen. Boom, then it shows you when it's done, as you hit enter. Boom, that's done. Then it pops up what's called a summary file here, which is the main output that many people use. There's a few sections on it I'll go over quickly. The top part
he sent out an email that he had a doctor's appointment.
Gives data on how the summary was generated, aggregate totals, total time captured in the log, total time in level 1 business functions. Okay, so one of the things you can tell here is, if it's a UBE, well, how much time was spent running C code versus how much time was spending running event rules code. I mean, this one in particular, because it says 96% of the time was spent in level 1 business functions, it means That's a very valuable piece of high-level information, right? Because it tells me I'm not going to bother looking at event rules code. I'm going to go look right at C code. And the business function summary has a list below of every business function that was called. Okay, the count, the total, the average, the maximum and minimum time that it ran. Okay. There's also a section on various stats of, again, E1-centric type of items. Business functions that return something, other than the good value for business functions to return, which is 0. 1, 2, 3 are error or warning codes at various levels, and 99 is kind of a nasty code. Usually means the business function fell over or abnormally ended some respects. There are reports on mismatches of init and free behaviors. There are stats on JDE cache operations. Okay, so just going through quickly what's in there. There is a detailed section on every individual business function. Right? It shows how many times that business function was called, what were the return values, what tables did it access, and what operations against those tables, select, insert, update, deletes. What were the parent business functions that called it and what were all its children, and a histogram breakout of the time spent. So again, it's a drill down. Okay, everything in blue you see there is a hyperlink that you can click into the parents, click into the children. You can follow a call stack in this manner. Okay, there is a section of table counts. So it's, in this time, instead of listing all the business functions, why it lists every table that had operations that were reported in that log. What operations, open and close is the O and the C, then SIDU is select, insert, update, delete, and from which business functions did all of this get called. If you see top level, that means the event rules level. It means the tool's very top level, not in a C business function. Okay, so you've got that information. You've also got timing stats as another section, meaning for every one of these tables and all the select, insert, delete operations vertically here for each table, about what was the time spent, what was the total time spent, what was the maximum time, what was the average time, what was the longest call, shortest call, etc. So how much time was spent in table I/O. Then there is a section on what I call debug strings, that you can, in that debug strings edit window that's over there on the left, you can type in a case-sensitive search string that LogParse will then, in addition to everything else it searches for, that you get automatically, also do a search for the strings you enter here. Okay, this is helpful that if you want to look for a certain token in the log that you're aware of, and then you want to see from where in the log did it occur, it'll show you that. It'll show you that in the proper context. It's fairly standard to always include select, insert, update, delete, that even though you get the counts of those of individual tables by default, what happens is you get what's called a call stack file, and it'll put everything here in the proper context in that call stack file. We'll see that a couple of slides from now. The next output is called a timing gaps file. And oftentimes this is a good place to find low-hanging fruit if it exists in the process that you're evaluating. It's often the first output you examine. Okay? It tells you where is time spent in large chunks. A good example is long-running individual SQL statements are often found in the timing gaps file. Okay? A good generic guideline is that for UBEs, well, UBEs are batch jobs, right? And as such, they should kind of always be doing something. They shouldn't be waiting. If you see a UBE and the timing gaps file is filled with a significant portion of runtime that's spent in gaps, that's kind of a performance red flag. Okay, UBE shouldn't be waiting, UBE should be doing. So you want to know why is it doing that. Interactive logs, on the other hand, the gaps in there often represent periods of inactivity, okay, when the user is not moving the cursor, not clicking something. So you have to, when you're analyzing interactive logs, you've got to kind of map when an action occurred, when downtime occurred, okay, which is why when you're collecting interactive logs, say a call object kernel running business functions that are initiated by that interactive log, you're going to have some awareness of, you know, when the breaks in the action were, when things are running, when things weren't, and those logs should be kept as small as possible, okay, so you don't have a lot of downtime to sit through. It's often a good idea to record approximate timings of use case events that you can correlate with the logs, and you can help match up kind of the cryptic notation of the log with end user events. We'll get into that. So here's an example of what a timing gap looks like. It's kind of small, okay. The right place to find this low-hanging fruit, no pun intended. Oftentimes, it's good to view this in a text editor like TextPad, because a TextPad, you can cut and paste things in a columnar fashion, so you can select on columns of data, put them into spreadsheets. Sometimes the data is suitable for that. Sometimes quick solutions will come from here. If you have, sometimes what you'll see is the line in there that has a gap after it is a select statement, or sometimes you'll see a bunch of long selects. Aha, that's, you go right to there before you look at anything else if you see a significant amount of time there. So what the timing gaps file is, just at its simplest, is anywhere in the log file where you have more than a certain threshold amount of time before the next line. And that's configurable. And here, if you can read it with the size, it's 20 milliseconds. So any line that has more than 20 milliseconds from the previous line, you would flag that, put it in the timing gaps file. Now you can tweak that sensitivity up or down. You know, 20 milliseconds works well for a lot. Some people use 200 milliseconds, you know, or different values. But in any event, you know, flag places where there's a gap in the timestamps as being potentially performance issues. Not always, but potentially. So profiling of log parse is, again, like we insinuated before, is often an iterative process that you run it the first time, then you rerun it while generating this thing called a call stack, which is the third output besides the summary and the timing gaps file. It's much larger than either of those two files. What you can think of it as is a reformatted version of the original log file, but still it will usually be a lot smaller. You want to use an editor like TextPad or something called LTF that's intended to open large files to look at it. Don't want to use Notepad. It's not very good at anything larger than a few megs. It shows the flow of Enterprise One business function logic. And any debug strings and timing gaps will appear in the proper context of that stack, all right? SQL statements will appear there too if you've added select, insert, and delete to the debug statement. Now here's an example, okay? Here's an example of a log file that has been cast into this call stack format. What you can see here is the enter and exit with the number. What that is the level of business functions in the business function call flow. Again, you can see here, I see in this one, it goes up to 4 levels deep. I've seen them 10 or 11 levels deep. And indented to the proper level are other things I've included in debug strings. All the select, insert, delete operations, okay, are there. So what this tells me here is, for example, here's this select statement down here, the 0005 that gets called from get UDC in a call that returned a 2 and took 3,344 milliseconds. Okay, if you can read that down here. And the select, insert, update, deletes get included because I've included them in debug string searches. In addition to, you can see there's other things, these H caches, increment cache count to such and such. Those have been included because those were included in the debug strings when I ran this thing. Okay, and I may have included that because I wanted to analyze kind of visually the flow. How do these cache counts go up and down over time as the process, you know, progresses? And this is often a very useful thing that you can't get from the raw log file because of the way it's formatted. So an important piece of value added that maybe you don't use, I know a lot of internal apps developers use it, is the ability to generate one of these call stacks and cast the logic into this visual flow where you can kind of see what's happening at different levels. You can see what business functions call what operations to what tables and whatnot. And that's what the call stat file is for. It's often helpful for some detailed analysis. There is an underscore UBE file, and any lines in the debug log containing the string dash dash UBE dash dash will be included. So UBE-oriented operations are here. Typically, a large, more commonly used in a search for UBE tagged string is unterminated caches, okay? Because large numbers of caches that are not terminated can have performance and memory implications, okay? So this is a way to find those quickly, right? In addition to other things like every time a subsystem is called, they'll have that UBE tag there as well. So that's something to look for as well. Other outputs, you've got underscore BSFN and underscore TBLE files. Those are CSV formatted files containing all the business functions and table stats. Same as they are in the summary file, but now you can open them in Excel. They'll come out in nice, neat columns. You can add, total, sort, and do all of that stuff. Some people find that useful. Some tips on how to properly collect the logs so that you can use Performance Workbench effectively and accurately. First of all, don't use debug logs from a fat client, okay? And there is a whole presentation out there for why that's a bad idea. It's titled, UBEs on the Client, a Bad Idea, okay? In the Performance Library, 978.813.1. There's a dozen reasons why, okay? We don't do anything in the fat client anymore short of deployment type issues, maintenance type issues, and whatnot. But we basically don't support any apps running in a fat client, UBE or interactive, again, that are other than building packages, things like that, okay? I always use debug level 1. A big misconception is people use level 6, except in unusual cases, okay? And there is, I refer to the Performance Library again. Tales from the Performance Crew Episode 2 shows why you might want to use higher than level 1. But the bottom line is that level 1 will still give you everything that a regular debug log gives you, plus a lot of UBE-specific information that does not have timestamps, okay? So anything higher than level 1 gives you extra fluff in the log that does not help the analysis, that is not relevant to performance, and often can skew and distort the data. So use debug level 1, okay, which keeps the UBE stuff to a minimum. You know, everything you normally need is at level 1. Level 6 just gives you a lot of details that you don't really need and makes the log files a lot larger. Some any settings. Okay, output equals file, you all know that. Dump LPDS. Dump LPDS is an important one. It also reduces the size of the logs. It also eliminates a lot of data that is not relevant to most analysis. What that does is suppresses dumping out the business function data structure twice for every business function call. Again, sometimes you want to see what those arguments are. Sometimes it's relevant. Sometimes it matters what you pass to the business function to performance. However, the default is turn it off. Okay? And there is not a server manager way to do that or a Google way that I'm aware of. You've got to do it in the actual ini file itself. Okay? So when you're launching UBEs interactively, the things to do is this. You check this box over here, tracing. So that gives you your debug log, but again, UBE logging level should be 1, not 6. Okay, as long as you get the tracing on, then you've got all the bug information. This logging level gives you stuff over and above what's in standard debugging that you don't really need. So that's log parse. The next two parts of Performance Workbench are SQL parse and Jazz parse. We'll go through those fairly quickly. Again, SQL parse, you most commonly use them against UBEs in call object kernel enterprise server logs. I gave you some advice on best initial settings. I like to use parse level 3. The tables to parse, it'll vary, okay? I can say this, there is no option to automatically do all tables. It would take too long, okay? You want to use tables that are based on what came out of your analysis from just running log parse. What tables do you want to focus on, okay? And the hands-on exercise, I had him do about 9 tables here, all right? So you have to actually type in which tables you want to parse, okay? Typically, you know which tables to parse of the fact you've gotten that information on the log parse. Again, the log parse points out which tables should be researched further, which ones had more I/O, which ones, based on the timing information, what do you just spend time in? Why would you then want to run SQL parse? Well, you want to look at the SQL itself. Maybe are you using primary key? Do we have redundant I/O to the database selecting the same record? You might want to pull the SQL out of the log for external testing using interactive query tools, okay? Using get explain plans, things like that. All right. So again, in the hands-on exercise, we had them run SQL parse, and they've got outputs, okay, that are in a directory that it's named the base file name underscore SQL dir, and you have one analysis file that's called SQL stats. Okay, the SQL stats is on the right. It'll tell you what file you ran against. It'll tell you what tables, okay, you ran, and it'll tell you how many of each type of operation, select, update, insert, delete, and how many of those operations were unique. Okay, in other words, if I see, for example, this 40070 here, says 19,875 selects, but only 51 of them were unique. What that tells me is that I've run the same 51 selects almost 20,000 times, which means there's redundancy in the I/O, which means there could be an opportunity for caching or storing that data someplace rather than going to the database all those times and getting it. Okay? Now, if you look on the right-hand side, you see that for each table there are 4 files that separate out, that pull out all the select, insert, update, delete statements separately, shows you what they are, okay? So I can actually see what data was run and a count of how many times each select got run. So you see some of them here run 100 times, some of these are run only 4 times. So I might have an issue of performance that has hotspots in it that I can locate by doing this type of analysis. I might have 20,000, selects against something, and maybe there's 100 different SQL, but maybe 19,000 of them were against one item, say. They're not evenly distributed against all items, so this can tell me, do I have some kind of a skewing in the data that triggers some issue, that triggers looping or whatnot? I can tell that intuitively by looking at these selects. Again, now that I have them in a text format, you can pull out ones that are interesting or that are called most often. You can run them through explain plan tools. You can run them through SQL analysis tools. You can look at what data it outputs. You can look at the primary keys for these tables, and am I using primary key? Do I have extraneous keys, partial keys, that type of thing. So all of that type of analysis is made easier by running SQL parse and pulling out the SQL in this organized and structured way. Finally, JAS parse. The JAS parse tool is the 3rd tool in the Performance Workbench suite. It's for JAS server debug logs. It gives you profiling data, again, based on business functions, this time event rules, system functions, SQL, and other searchable items. So slightly different there. So again, a suggestion of best initial settings. Kind of the lower center part of the Performance Workbench interface gives you the configuration of JAS parse. I like to use level 2. I like to check the timing gaps and call stack files. Okay, options. Okay. So again, we had when this was done as an interactive exercise, we had them run a particular log, get outputs. The JAS summary file looks similar but a little bit different to what you get from the log parse summary file. And I have a section on business functions that are called, but then you have below it which ER events made calls to those business functions, okay? And in addition, anything that are large contributors, to business functions which show up as taking the most amount of time get highlighted in green. Anything highlighted in yellow are parents' ER events of large contributed business functions, okay? And you notice I include while loops as well as ER events, because while loops in ER are notorious time sinks, especially in interactive applications, okay? They are notoriously slow. They process slow, especially when the while loops, you know, go through a whole lot of iterations. So this analysis in the JAS parse output calls that out, okay? There is a section on system function stats, how many times they were called, and what parent ER events, and how many times did each call the given system function. So add item, clear selection, delete grid row, all of those things are called out and documented. Then there is a section, a third section, on event rules data. Has a lot of interesting and useful information here, okay? I have the event rule here. Highlighted in red are event rules which, again, take a significant amount of time. There are various types of children that an event rule can have. Business functions, while loops, table I/O, system functions, and other ER events. And then over here it tells you if that information is available, how much time was spent there. So here, this system function, post button clicked in it, its max is 86 seconds, but it had a child event here that took 83 of those 86 seconds. Okay, so you can see, you know, again, it's the same drill down HTML hyperlink type of a report. There is a section on SQL data as well. What SQL got called and from which ER operations, so similar to what you get. There's also a call stack file capability with the JAS logs. Instead of business functions, it's oriented around the ER events. And again, it's the same hierarchical flow. An ER event can call an ER event, can call another ER event. You can see I've got up to level 7 that I can see here. They're labeled as ER start and ER end. And then there's this tag here for how many milliseconds it took. If I've got system functions, it'll show you in what context and at what level those were called. It's got all the business functions and their runtimes. Also includes any timing gaps are called out here, okay? So if there's a gap, something that took a very long amount of time, it shows exactly where and when it happened, okay? Select statements, and again, we said that you've got levels in the ER call stack. So again, provides that same kind of visual analysis. If you want to look at an interactive form and all the buttons that were pushed, all the events that were called, how much time did it take, etc. More details. There is on, again, 978.813.1. If you haven't memorized that by now, you're probably tired of hearing it. There is a presentation called Profiling and All That Jazz, okay, that shows a detailed case study of that. So how do you collect interactive logs properly? Well, in the .properties file, the jazz-log.properties, there's some settings you should look at. Level should be debug. Format should be apps. Append should be true, so you don't stop on the log. Max file size, you want to have that big. The default is 10 megabytes. I don't like 10 megabytes. 10 megabytes is nothing because you'll end up with a lot of underscore backup files, and you want to have everything in as few files as possible. I set that to 500 megabytes if I'm collecting logs that I want to analyze with Jazz Log Parse, and do a backup index of like 20, just so you're sure that you won't circle around and stomp on things, all right? That's what I'd recommend, that the default is 10 megabytes, don't have it there. And again, then the component, minimum those 5 things that I've included there. So in other words, in order to get the data that will give you the ability to do this analysis, right? Again, the analysis, this process and the tool is only as good as the data. You need to collect the data properly using the proper settings. I would recommend these. It's critical that the level is set to debug because business function timing data is only included at that level. You won't get timings for business functions if the level is not debugged, okay? Max file size parameter, we've been over that, just so that you don't want individual segments. You want everything in one file if possible. And if you don't, you've got to append the files, in order to have that flow. You cannot run them separately and have the results come out properly. Okay? This is intended to be run against one file. The component parameter needs to be set so that you've got everything you need, etc. Jazz log parse is intended only for Jazz debug logs which contain output from a single user. It's not particularly well suited for logs containing so you want to specify logging for specific users, and you can do that in Server Manager. Okay, you can, for a specific user, set the logging level. Okay, so that you've got logs for only one user. Okay, and there's how to do that. Again, we'll go through this quickly. There's a typical procedure for collecting interactive logs from an actual customer that involves a sales order or a configurator case. Important points this year. The log has to capture the problematic behavior. Again, you got to have the security tape that shows the guy breaking into the store, which means it's got to be the right part of the store, the right time of day, and the right store, right? Got to have the use case input data and configuration must all be accurate, the same as what generates the problem. The log should not be cluttered with data from other operations. You should run the procedure and collect the log, and don't do extra stuff. We won't read all of these words specifically, but we'll make this presentation available. You can go through this. So, but the point is, you can see how detailed it is. Okay, you can see we don't just say go get a log. We put down in painful detail. Here's how you got to do it. Here are the steps. Here's what you do next. Here's the settings you use. Boom. Bring up E1. Boom. Run the use case. At these steps, note the approximate minute and second that, you did all of these things. It may seem painful. It may seem, kind of laborious, but if you want to pinpoint where time is being spent, this is what you often have to do, because the logs are one thing, but correlating them to an actual user doing his actual work is another. That doesn't happen automatically. You've got to have information about how a user uses the app, that makes the data make sense. Okay, I'm very specific about deliverables. Okay, so after you've done all this, you should have 2 zip files that contain the logs, that contain the timings, specific. Okay, so there's no ambiguity. Interactive logs are particularly important because they're different than UBE. All you do is run it, right? Oh, and then the log file's in print queue. Okay, pretty easy. You just got to get the data selection, processing options, and whatnot correct. And I find it helpful, like I said, to record the approximate timings of use case events that can be correlated with those in the logs. Okay, so here's an example from what this customer did. I mean, just looking at some of these things. Time taken from tabbing out of the 4210 detail line to the P3210 opening and finishing and loading of segments. When did it start? When did it end? And notice we've picked events here that take multiple tens of seconds. And that was the problem, that things took 20 and 30 seconds. So you can be accurate within a couple of seconds. It's the super accuracy is not important this year. Get it off of a stopwatch or something. But the point is, you should know approximately when these user level events occurred and started and finished. That way you can kind of cross-correlate to what's in the debug log. You can say, aha, getting back to the 3210 after hitting validate configuration, oh yeah, that correlates to this business function, validate, SEG and UDC value right here. I get it. That happened at 10/21/32, which is the same time as when I recorded, this event. So that's helpful. So again, a point of all of this is detailed and well thought out log collection procedures are critical to capture the proper use case, and the log ought to be thoroughly documented for the use case it contains and how the data was captured. Okay. So summary, what have we gone over today? Performance Workbench is a tool. It's not a replacement for understanding performance concepts. It's a data reduction tool, is Performance Workbench, of debug logs into statistically summarized reports of the logs. It works well with large debug logs. The larger the pile of data you got, the more statistically accurate you're going to be. It's only as good as the data that it eats. Okay? You've got to properly collect the input debug logs, proper settings, proper use case, proper configuration, significantly large sample size. Can't emphasize that enough. 3 parts of Performance Workbench: log parse, SQL parse, Jazz parse. We give you recommended settings and showed you the main outputs: timing gaps, summary, call stack, Jazz log parse. Recommendations for UBE logging, details on how to collect interactive logs. There's a lot of detail there. Okay, you've got to be very deliberate, okay, and very specific about your procedures to make sure you collect the proper logs from the proper use case, and usually that doesn't happen if you just say, go get logs of this application. Okay, it doesn't happen through osmosis, okay, it's got to have a lot of detail. And again, the value added in spending all that time is going to be you know what you're dealing with. You know what pile of data this log is. You record approximate timings of use case events is an important technique. There's details in the help files and in the performance library. So that being the case, we're just about done and just about on time. But I will take extra minutes if anybody has any questions, comments of any sort. Anything out there? People are either deep in thought or deeply asleep. Hello?
Actually, I have a question.
Absolutely.
Can you hear me?
Yes.
Kathy Martin with Manage Course. Everything with this is so great if you have the UBE where you can duplicate the problem. Like, let's say they report a problem with the UBE, and then you say, okay, let's run it and get the logs. But what about instances where you have an ongoing UBE that's ran 100 times a day, 99% of the time it runs fine, and it's launched from, say, scheduler, and 1% of that time that UBE fails for various reasons, and we're thinking data. How can I incorporate things into a scenario like this, into a scenario like that?
Okay, good question. The question was, didn't hear that what happens you get something that's run a whole lot of times, like a UBE, it's run 100 times a day, and once in a while it fails. You know, I mean, how do you go and, you know, chase that shadow, if you will? Well, the thing is, number one, if it only happens 1% of the time, is it an urgent, critical thing? You know, is the thing. Not saying you don't have to solve it, but I'm saying, you know, do you have extra time, or is it, I mean, it might be. It may be that one UBE is something that's going to shut things down, something that's going to have financial implications or whatever it might be. So you want to consider what the priority is of it, you know, at a larger, before we get into analysis techniques. Second of all, a lot of events that appear random that you can't reproduce, I submit to you, there is a pattern that even though you can't reproduce it on command, what you can do is you can say, well, I don't know what particular time I run it it's going to happen, but I know it's going to happen twice a day, say, 200 times a day, right? You can tell about how many times a day it is going to happen. And that's the start. Identify what the larger scale patterns are, right? Even if you can't on demand reproduce it, identify what is happening, you know, in terms of that. Second of all, is there something in the JDE log, in the error log, that it puts up? That's the first thing you look at. Okay, because if a UBE ended in error, does it mean ended in an E? Does it mean it ab-ended, as in the code crashed? Or did it error out gracefully? You know, if it errored out gracefully, there's 2 places you can usually find issues. Number one, in the JDE log, you know, because JDE log should normally be, you know, about a dozen lines worth. The UBE started, the UBE ended, you know, but for something that ended in error, you know, usually there'll be some indication in there. The other indication is that if this UBE gives you a PDF, okay, oftentimes if there was an error or something went wrong, PDF will often have a line or 2 in there as far as, you should be seeing a page of data here, but I'm not. So what's going on there is the thing. But the other thing is, if there are UBEs that run only a minute or 2, you know, is that what you said? I mean, how long, they run very short periods of time, say? You could even consider, you know, Depending on how you can set this up through scheduler, it probably runs in the command line. I guess even for a day, you know, turning on debug logging, you know, and before the customer would throw a fit at that saying we can't do that, well, it would only be for this one UBE, and we'll only do it for a day. Okay, that it's kind of one of those you got to break eggs to make an omelet type of thing, and then we turn it off. And that the idea is that if maybe we do this 100 times with the logging on, maybe it takes 2 minutes instead of a minute, but let's find the one that broke, and then let's see what the log tells us. You know, so in a limited kind of a way, can I do that? Can we, you know, incur the overhead just for a day of enabling logging just for this one process? And put the word out to your users, yeah, they're going to take longer to run, okay, but we're going to be collecting data that's hopefully going to figure out, you know, it's going to let us capture this gremlin that's somehow in the system. But see, those are some approaches you can take. Best, too, if you can look at data and figure out, okay, when it happens, is there a certain time of day it happens? Okay. Is there a certain data range that it always seems to happen with? Certain types of inputs. When it happens, what are the inputs? You know, what are the characteristics of that particular run that makes it fail? You know, just things like that. You want to observe the patterns. You know, because there is a pattern there, but it's a question of, you know, you've got to look at the data in the right way in order to figure that out. I mean, that's, you know, hopefully a start.
All right. Well, thank you.
You're welcome. Any other questions?
Is the performance workbench at extra cost or included in the JD license, please?
Can you repeat that?
Yes. Is there a cost for using performance workbench, or is it included?
Oh, is there a cost? No, there's not. If you can go and log in to My Oracle support, you just go to well, first of all, go to 978.813.1, and on that page there will be a link to the page for Performance Workbench, which is 74 something. I don't even memorize it myself, but anyway, on that Performance Workbench library there is a link, or excuse me, it's a performance library, 978.813.1. In fact, let me go to the
It was in the beginning of the...
Yeah, it was at the beginning. 747328.1. If you can get at that page, then you can download, and there's no additional cost. Yep.
Okay, no cost.
Right.
Even for customer, for partner, customer, it's free. Free tools.
Yes, exactly.
Okay.
It's a tool, and it is for free for anyone who has an account that can log on to the My Oracle support, and anyone who owns our product, basically, can also get this. So yes, that's a good question. There's no additional cost, fees, anything like that.
Okay, thank you.
You're welcome. Anything else from anybody? Okay, well, so thank you for all coming here for, gee, what is this, July? Clayton, I guess, will be back next month to do whatever the things he does are. I don't know what extra announcements, segments, whatever that he usually has scheduled, but the regularly scheduled programming, so to speak, will continue next month. Thank you all for listening. I guess this recording will be out there wherever it usually is, in addition to the slide deck. We'll make available for that. Clayton is on vacation, but he's been sporadically responding to email, so hopefully we can get the logistics put together to get all that stuff out there where you can get it. You all can, I guess, if you've got any additional questions of something or anything about Performance Workbench in general, questions about baseball as well, I'll take, in addition to questions about motorcycles. I guess you better, you know, we can do that too, because software is boring all the time, right? So any event, you can do that, and thank you very much for participating.
Thank you.
Thank you.
Thank you. Bye-bye. Bye-bye.
Bye.
Bye-bye now.
Thank you.
Bye-bye. Thanks.
You're welcome.
Bye-bye.